Welcome to impattoreale.com. Today with me we have a special guest, Ray Toms, directly from New Zealand, and let me introduce you to you, Ray Toms. First of all, this is the first interview that I'm going to share on our new website, impattoreale.com. As you can hear, I'm not mother tongue in English, so sorry for my English. I will try to do my best, even if this is not my first language. I must do this interview because the information that Ray is going to share with us, I think, are full of value. So after these recordings, I will go to translate everything in Italian for the public that follow our work in Italian. And then, well, who is Ray Toms? How I knew him? You have to know that around 2-3 years ago, when I was searching on website about cycle, well, 10 years ago I fell in love about cycle. I started my research on cycle of markets, and then I started to study also cycle of life. I mean, cycle of climate, cycles of planets. Everything can be connected with cycles. And then researching about cycles, a day I found the website of Ray Toms. Um, Ray, it seems that there is a noise on the microphone. Is it possible? Do you hear a bit of noise? Oh, it's
There's a little bit of echo. A little bit of echo.
Okay, yeah. Is it possible? Okay. Yes, 2-3 years ago, on my research, I found the website of Ray, and I started to read his research about cycle because he's crazy for cycle, more crazy than me. I think he spent all of his life to research cycles, and he with these articles, with this work, he taught me so much things. He helped me to open my mind. So, so last year, on 2018, I expressed to him the desire to meet him, and I went to Auckland in New Zealand, and I had the confirmation. I had the confirm of what a great and such a big work he did about cycles in life, starting on markets also, and a lot of other stuff, and so. I made the promise to Ray. I said, well, Ray, I will start to bring some of your works to my public, to our public. And so I think that as first interview for our new website, this is for me a great honor to have him here. Well, speaking with Ray, you could start to speak about a lot of things, but we have only short time today. My idea is not to do now a seminar of 24 hours or maybe 1 week of seminar. So to start this work with Ray, I asked to him to speak about cycles of climates, because climate change is one of the main themes today. A lot of population is concerned about the climate change. And when I found that Ray researched about this theme, going back of thousands of years, well, I found something very interesting. Speaking about climate change, there is a lot of debate. There are people who knows, who think that climate change is because the human action, and this is the bigger part of the thinking of the thing today, of the people today, and there is another part, a little part of people that don't think that the human action is the main causes for the climate change that we are living today. Besides on that, there are a very long-term cycle that seems to rouse the climate change. So today I will go deeply with Ray about these themes, and well, I suggest you to watch this interview with an open mind. If you will open your mind, I think you will learn a lot of things at the end of this interview. And even if you will agree or disagree with what Ray is going to share to you, I think that we have a fact here. There is an history. There are a lot of data, historical data, and that's something that we cannot cancel. That's something that maybe uh, we should accept and start to think, starting from this data. So, Ray, uh, thank you from my heart to be here. I'm very grateful. And I pass to you the microphone. You can start with your presentation.
Okay, thanks, Roy. What I'd like to do is talk about the longest cycles down to the shortest ones that we know about in climate. It puts everything in perspective, you know. It's like starting with the universe and coming down to our little town. The longest cycles I found about in climate, I first came across in a book called Megacycles. And this was the proceedings of a conference of geologists quite a few years back. It was published by George Williams, who's an Australian geologist who's done a lot of very interesting work. But there was a group of geologists, and they discussed and agreed what they thought were the cycles in geology. And the ones that they first mentioned, there was one cycle, they said, about 600 million years, and other ones about 300 million years, 150 million years, 74 million years, and 37 million years. And you may notice each of these ones is a half of the preceding ones coming down. This is a very common thing we find in cycles that are related by ratios of 2 and sometimes ratios of 3, and occasionally other ratios. So later, I was to meet another professor of geology at Russia in Moscow, and he had worked out that the period of this longest cycle is 586.24 million years, a lot more accurate than the Westerners have got. And if we work that down through the halving of those cycles, we do come to the figures near 37 million, just 36.6 million, and so on years. So these cycles seem to be well established, and the graphs I'll show you at first will go through some. You'll see some of these cycles present. Now, one's geology, the other one's climate. What's the difference? Well, geology is a record of past climate, among other things. We can see when long periods were more wet or more dry, more hot or more cold. These things can be recorded in the isotope ratios. Some of these isotope ratios allow us to look back a little bit in thousands of years or hundreds of thousands of years. Others can allow us to look back millions or even hundreds of millions of years. So we'll go through them from the longer ones down to the shorter ones, and we can see there some of these records. Oops.
Are you going to share your screen? Right.
Yeah. So this one is this is going from about 550 million years ago until the present time, and you can see it's showing CO2 parts per million. So it was actually there are other ones that start down lower here, but the CO2 has gone up to about 6,000 parts per million, back down to about 300, back up to about 2,000, and back down to about 300, and then more recently it's risen to 400. So historically, CO2 has been as much as 30 times in the atmosphere as what it was more recently, and returned again to the level it started at, and then up again. So that's that shows us that CO2 in the past. Now, it's in this period, 600 million years ago to the present, is the period over which all complicated life forms on Earth developed. So we have, before that, there were only single-celled creatures, and the complicated life forms developed during this period. So it's when people say that CO2 going up to 500 or something is going to kill all life on Earth, it's patently wrong, because we have this long record of all life on Earth developing during this period. Here's another one showing a similar thing. This one is... Yep.
Sorry, Ray. I think if you maximize your windows, maybe we can see the...
Yeah, okay, let's see. Okay, are you seeing that okay?
Oh, no. Better come back.
Okay.
Okay. We have to go in this way.
Yeah, sorry. So we're seeing here this increase in CO2, reduce again, increase and reduce. And that's happening twice in 600 million years. So we've got a 300 million year cycle there. And there's some uncertainties about these, right? So it definitely went up a long way. This one is showing average global temperature as well as CO2. So we're seeing the same thing on CO2 going up, down, but we're seeing that the temperature has gone up high, come down, gone up, come down, gone up, come down, gone up, come down. So it's done it 4 times in the 600 million years. So that's about a 150 million year cycle. And we can see that the temperature range here is these highs are 15 degrees C higher than the lows. So huge variations in temperature over that long period of time. And the interesting thing is that although we saw both CO2 and temperature going up together here, the temperature came down while CO2 was high. Did the same thing here. The temperature came down while CO2 was high. Then it came back and they moved together. So sometimes they move together and sometimes they move in opposite directions.
Ray, what are the source of those images?
Most of these images have come from Wikipedia or other sites, peer-reviewed journals and such.
Anyway, from this image, on a very long term, we can see that there is not 100% correlation between the temperatures in blue and the CO2 in black, right?
Yeah. So this one is temperature. It's a more detailed one showing that there's the 4 main ups and downs, but there's a few other little variations as well. What happened there?
What's happened? Don't go ahead.
I just had trouble going to the next one. Here we go. So here, it's the same thing again. These are different examples from different people, how the temperatures varied, how the CO2's varied. So we're seeing again, this one's showing that you can see the 150 million year cycle there again and the 300. Same again, and sometimes there are these funny little bumps here, up and down, where they've got one spurious measurement, which I think they're taking to probably be some random thing, or it's just conceivable that in the distant past, sometimes things change very rapidly also. Now this one's interesting because they label it hothouse and icehouse, and you can see that over the 600 million years, they've gone 4 times into each. So it's a 150 million year cycle, and in the period they're calling icehouse, it's possible to have ice ages. At the deep parts of those, there are ice ages. When they talk about an ice age, it's important to know that an ice age is the period when it's possible to have frozen periods, but we're still in an ice age, but we're in what's called an interglacial. So we're in a period where there are ice ages, but every so often we pop out a little while. Now it's about every 100,000 years. So we're coming from the frozen situation. We've popped out of that about 10 or 12,000 years ago, and at some time soon we're liable to pop into the next one. Now all these ice ages in the recent times, where there's been a number of them, are all in this little short period down here in the middle of this ice house. So when we talk about temperatures going up, we're talking about going up a tiny bit within this ice house period, this ice age. So we're the periods of the very warm cycles here, when it was the hothouse, were far, far warmer than anything that anyone is talking about in the scariest scenarios. So that's the
Ray. In that so hot period,
Yep.
where human life as we know today.
There was life. There were complicated life forms. There were dinosaurs and things. Humans only appeared right down this end here, not a heck of a long time before the ice ages start. But there were mammals. There were mammals through the periods when it was hot and cold. We know that life can exist. The only possibility would be that life would be exterminated by these things is if the change was extremely rapid and life couldn't acclimatize. But given that there's the equator and the poles, there's a big difference there. It may be that life would have to live nearer the equator if things got really hot, but it would very quickly, with the genetic diversity that's there, adapt to the different climates again.
Okay.
Now I'm coming down to a shorter period of time. This shows us the last 65 million years, and we're seeing changes in temperature. Now, up here, we're seeing that the temperature was up 12 degrees higher, 4 degrees higher, and down here we've got 0 and -8. Now, this is taken from Vostok, a very cold place. So we're seeing a 20-degree difference from 50 million years ago to now, or to recent times. The temperature dropped 20 degrees in a period of 50 million years. Now we can see it didn't just drop, there were some ups and downs along the way, and during this period in particular there's a lot of rapid fluctuations. Now these fluctuations here are going in and out of ice ages, and that's happening every 100,000 years, so they're too small to show on the scale. We'll come to that finer scale later. This is worked out from the oxygen 18 isotopes present in things.
Ray, just to let you know, I don't see anymore your cursor, your mouse, your cursor. So when you point on some specific part of the charts, maybe you can recall also how many million years ago, or some details that can.
Are you seeing my mouse there now?
No, I don't know why, but when we
is it showing now?
No, it's not appearing anymore.
I don't know why that is.
Yeah,
sorry.
I don't know, but anyway, it's not important. Just when you point on some part of the charts, if you can help us understand where you are.
Yeah. Okay. So right down the right-hand side there, there's a lot of wiggles over. In the last million years or so, we've been going in and out of ice ages about every 100,000 years. Now this is expanding that period. This is the last 450,000 years, and this is showing us methane and carbon dioxide. Now what we can see is that in that time, that's 4 periods of 100,000 years. We've gone into an ice age, spent a long time there, popped out briefly, gone in again, popped out briefly, gone in again, popped out briefly, gone in again, and popped out this time slightly longer. So we can see that that period coming above the 0 degrees there more recently has been a longer period than the previous ones. Now, in other graphs I've seen that's slightly different. This is showing the carbon dioxide and methane level. When we go to temperature, it's slightly different to that. There's no doubt that temperature has taken off in a crazy manner there, methane. One assumes that that's because of mining for fossil fuels, and a lot of that's been released. Bear in mind that's only 1,800 parts per billion, so it's only 1.8 parts per million. It's still quite small, but it does have a slight effect. The carbon dioxide has gone. It's mostly varied from about 200 to 300 parts per million, but in the last century, it's reached 400 parts per million now. And so the question is that due to humans? It's possible not. Oh, this is one I should have showed earlier. It's showing you the last 542 million years. For some reason, geologists often like to do their scales backwards, so time runs from the right to the left. I've just shown there my best estimates of the different cycle lengths. It's showing a 146.5 million year cycle is the green graph. The blue line is the actual fluctuations in temperature. The green one is showing a regular 146 million year cycle, and you can see it fits the data quite well. Then I've done a series of green dots down there. They are at 36.7 million year spacings, and you can see they're slightly various. Sometimes they're slightly closer, sometimes further away, but there are up and downs of that time scale as well. And the four parts in blue at the bottom are showing the periods when you can have glacial periods. This one is showing you carbon dioxide variations over the last 400 and something million years. It's the same as the one we saw before, it's just a little clearer, and it's showing you how it's gone up a lot more in the last 100 years or so from where it normally goes. This is a bit longer period again. This one's going back, oh no, sorry, it's shorter than those. It's showing you the last 10,000 years. Again, it's got time running from right to left. You can see the orange line wiggling up and down 4 times in a bit there. That one's called the Hellstart cycle. It's a 2,300 year cycle. It's in, you can read about it in Wikipedia. It's an accepted cycle as existing. Another accepted one is a 208 year cycle, and that's they are both fairly important in terms of present events. The 208 year cycle is interesting because during the 1800s it was moving down. During the 1900s it was moving up. During the 1700s, it was moving up, and the 1600s down. And you can trace it back a long way. It's been going up and down every 200 years. Now, this cycle is found in both the sun and in the climate. Raymond Wheeler reported it in the climate from in the early 1900s, on the mid-1900s. He reported this, and it's been found in various solar proxies, which are isotopes that are stored in various formations that they can trace this back. The 2,300 year cycle is fairly well established as well. The importance of those, the 2,300 year cycle is still going up at present. In the recent couple of 100 year cycles, we can see these 208 year cycle going up and down. We can also see a clear 60 year cycle, around about 60, 55, 60-ish years. So, for example, in the around 1940, in the 30s in America, they had what was called the Dust Bowl, where all of the wheat growing areas blew away in the wind because it got so hot and parched that the areas suffered seriously. Around that period, up to around 1940-ish and a little after, many of the records for the hottest temperatures in the various states were made, and many of those have not been broken to this day. So when they tell you that we're far warmer than we were, in America that's not the case. Temperatures now are only about similar to what they were in around 1940. In between time, on the 60-year cycle, we had a big dip to around 1970. At that time, there were many articles published in newspapers and in journals and things saying we are about to enter a new ice age. Temperatures are heading down. It's a terrible thing that's happening. It's all going. The world's going to chaos from going in the next ice age. And some of the same universities that at that stage were saying we're entering a new ice age are now saying we've got runaway global warming. Just 30 years later from the upturn in things that happened, not according to what they said. And I should mention that the people that are saying this, they're writing stuff for the IPCC. The things that they're writing about what's to be expected with the coming temperatures, they've been making predictions now for 20 or 30 years for periods ahead, what's going to happen if we don't do this. All of their predictions have been wrong. They've been disastrously wrong in their predictions. This is another one going back over the long period, global sea level fluctuations as well. And you can see, again, it's running in time right to left, the sea level. That's two different ones from different sources. You can see they're similar, but not exactly the same. And you can see that over 600 million years, the sea level has had a huge rise and fall, another huge rise and fall. So the sea level change, the sea level has been as much as 300 or 400 meters higher than it is now at times in the past. And more recently, in the last ice age, it was quite considerably lower than now, maybe 100 meters at some time. So sea level's certainly something that we should think about. This is a graph of temperature over the last 450,000 years, and you can see we've been longer. The right-hand one is our current one. You can see we've been out of an ice age for longer than other periods, which means that there is a significant risk that we're going to fall back into another ice age in the not too distant future. Now, in those other graphs, we're talking about hundreds of millions of years. This one we're talking about in thousands of years. In the next couple of thousand years, it's quite possible we'll fall back into an ice age.
Ray, this is very, very, very different. Okay, this is quite different from what we are hearing in the news, in the television. We are reading on newspaper. I mean, maybe no one or very few people all around the world are pricing right now risks for ice age. I think that we are most concentrated about an hot age.
Yeah. But we are, in fact, historically, although we're at a warm period in terms of the last million years, we're hot because we've come out of an ice age. In terms of hundreds of million years, we're in an incredibly cold time. So it pays to have this perspective about when life has developed and so on. There's a lot more life near the equators than there is at the poles. And that says to me that we can cope with warming much better than we can cope with cooling. Now, this is coming now. One of the things that happened over the periods of those ice ages, they are able to measure both the temperature and the carbon dioxide content from these frozen ice cores. They get the temperature from the oxygen-18 ratio, and they get the they use the carbon-14, I think. What do they use? I won't say. I may have it wrong, but they can measure both they measure the carbon dioxide content frozen into the air, frozen into the ice deposits. And one of the things that happened in that was that someone did a study to see they had the graphs that showed they moved similarly, but someone did a graph to show, or a study to show, did one lead the other? If the carbon dioxide was causing temperature to rise as it rose, we would expect the carbon dioxide to start rising first, then the temperature. But what they actually found was the temperature began to rise, and then about 800 years later, the carbon dioxide started chasing it. And when it fell, the same. So the temperature was preceding the carbon dioxide movements by about 800 years. Now, this has been published in peer-reviewed journals and so on, and it appears to be well proven. I wanted to know, is what we're having happening now, where things are happening perhaps a little faster, is that different? What's going on? So what I did is I got what you see here is a graph from the 1950s through to 2000 something, and it shows two things. One is global land ocean temperature, and the other one is CO2. The CO2 is measured in Hawaii. It's the longest record we have of that, and the other one is called GHCN, global land ocean temperature. And
right. We have the temperature, the ocean temperature is in red, right? And in black is this.
Yes. The temperature is in red, and the CO2 is in black. Now, if you look at each of the peaks, you can see that the red one hits a peak. This is the rate of change of temperature and the rate of change of carbon dioxide. I use rate of change because we're interested in what's going to happen, which is the change. And if you just have two graphs that are rising, they look so similar, you can't see anything. But if you look at how fast they're changing, it can tell you which change is causing the other change. And you can see on those peaks, the red peak happens ahead of the black one. Pretty consistently, and the trough's the same. Now, and you can also see that, like for example, in 1973, where you got a big red peak, you got a big black peak, but in some other periods where you got a smaller one, you got a smaller one. That's not a very strong correlation, but you can see there's a tendency. Now, I took the data and I did another study. I slide them backwards and forwards in time to see how much they correlate. And it turns out that the temperature leads by 6 months the CO2. At that point, there's a better than 0.4 correlation between them. At other times, at any time when the CO2 is leading the temperature, there's only the best 0.15 correlation, a far lower correlation, far lower explanation of what's happening. And so it's quite clear that the CO2 is not causing the CO2 change is not causing the temperature change. Now, what does this mean? How can we explain this? And why is there this one period of 800 years in the Ice Age ones and a period of just 6 months in the more immediate changes? And I began to look at that, and I found that if I went to NOAA website, and they showed the movements of carbon between the atmosphere, between plants. Plants can exist in trees for a long time. Sometimes it goes into the soil through the roots, and also from the atmosphere, it can get dissolved in the oceans, in the surface layers of the oceans, and also then go into the deep layers of the oceans. And again, it can come back from the deep layers to the surface, and from the surface, it can come out. Now, I remembered that from my elementary chemistry studies, that gases, the amount of gas you can dissolve in water varies as a function of temperature. When the temperatures rise, less gas can be dissolved in the water. So this means that if we have a rise in temperature in the atmosphere, and that's also going to be the temperature is the land and the ocean, so the surface of the ocean is this temperature, then as the temperature rises, some carbon dioxide that was dissolved in the ocean now has to come out into the atmosphere. So this graph that we've got here makes perfect sense in that, and 6 months seems a reasonable time for the gases in the near surface layers to be able to come out into the atmosphere. Or in the other case, if the temperature is falling a bit in the ocean surface, then the gases can get redissolved into the surface waters. Okay, going to the longer period, I did read years ago that water, that's the meltwater from the Antarctic, coming off the Antarctic, is so cold that even though it's got no salt in it, it goes to the bottom of the ocean, and it goes up the Atlantic Ocean, weaving its way. It takes 800 years to reach the North Atlantic, where it finally comes and mixes with the other water. It loses its temperature and mixes in again. In the Pacific Ocean, it takes 2,000 years. But what we're seeing is this period of 800 years is around about the right time scale where the deep oceans can mix with the surface oceans. This means that when we are going in and out of ice ages, this 800-year lag we see between the temperature and the carbon dioxide in the atmosphere can be understood as the exchange of carbon dioxide dissolved in the water from the deep oceans up to the atmosphere, whereas this 6 month time lag is from the very shallow, from the surface layers. And to me, that all makes perfect sense of what's going on. It says nothing about hothouse gases. I think that a lot of the stuff that's been done about hothouse gases is not relevant, and it's not even correct. If it was correct, we would see this graph being the other way around. We would see that carbon dioxide would lead the temperature change, not follow it. So until someone can explain to me why in the two cases of the deep ocean time and the shallow ocean, if they can't explain why the temperature change precedes a carbon dioxide change, then everything they say about carbon dioxide and being the cause and humans being the cause of climate change is wrong.
That's very interesting to me, Ray. As I said at the first part of this video, of these recordings, in the last year or so, when I started to speak about people about climate change theme, I saw a lot of I don't know in English maybe the right word, but
Parrot?
yeah.
Is it a parrot?
People have their things, their idea,
Yeah.
and I saw that it's very hard to the people that have their idea about climate change to help them to think that maybe something different can be possible. It's very hard to have a discussion, an open discussion.
Yes, agree.
I don't know what is the truth. I don't know if this is the truth, if there is another truth, if the truth is what the main television and newspaper tell us. I don't know what is the truth, but what I know is that I would like to see around these themes an open mind.
Yes.
I don't see open mind when we speak about climate change. It's like politics. There is a left, there is a right, and anyone wants to know, wants to say nothing. And so that's why when I read for the first time your research about climate change, I thought, well, at least we will try to put also these charts, this idea to the people. Then anyone will have to put their mind in the process. But I would not like to take any information that are spreading around the world about climate change as the truth. There is a lot of research to do. I think there is still a lot of research to do about these themes. I like so much finding cycles in markets. That maybe was the first reason that brought to me to your research. And someone could think, Roy, what is the connection between cycles of markets and climate change? And I think there is a huge correlation. Let's try to think only about the commodities markets. Let's say grains, for example. There is a huge connection with the climate change, but not only, because as you told to me, I hope to use the right verbs in past. The climate change affects also, or can affect also, the human reaction, the human emotion. So how human take choices in their daily lives. So I think this is a huge themes, and with this video we just in Italian we say scalfito la superficie. I don't know in English how it is, but we have just started to touch some part of this big thing, and I hope there will be another opportunity to go even deeply about this thing, to touch also other themes and to see other charts that we didn't have time to see today in this first video. Anyway, I will say thank you very much, Ray.
Okay, let me add one thing, because when you put this up, some people are going to say, "Oh, he's being paid by the oil industry" or something like that. Now, I retired with enough money to live off 30 years ago, and I've done a lot of cycles research and other things in that time. I have never had any money from any oil company or anyone else to do my cycles research. It's all, as far as I'm concerned, I'm a pure scientist studying it, and I'm not even like in a university. The people in universities, they have to go down a narrow path in order to please other scientists and other people with a peer review system and all of this. I don't do any of that. I just do my research. I follow where it takes me. I find the facts. I'm a greenie from way back, and originally I believed that that humans probably were responsible for all this carbon dioxide and all of that. But when I researched, I found it was the opposite to what I expected. I'm a scientist. I accept what I find. That's how it is.
Ray, I think you are one of the greatest and clever minds that I have found in my life, actually, in my research. And I think that your spirit is the spirit of a real scientist. Your approach, your spirit, by how I see the life and how I intend the research of any fields of life. I think you are a very scientist. That's my idea.
Okay.
Thank you very much, Ray.
Okay, thanks, Roy. Thanks a lot.
Thank you, and I hope to have here for another time in the future.
Sure.
Thank you, Ray.
Yeah. Okay.
Bye-bye.
Bye.